Hi, I'm Marten Forrest from the AGRC 2019 class, and today I'm going to present an oral report called Fluctuations of Abundance in Three Species of Mouse Deer Communities over a 5-year period in the Bukit Barisan National Park, Indonesia. The three species I've chosen are the greater mouse deer, Tragulus napu, the Java mouse deer, Tragulus javanicus, and the lesser mouse deer, Tragulus canchal. I compared two factors to measure species diversity and richness using the Simpson's Index and Simpson's Diversity Index. Firstly, species diversity during dispersal at different levels of moon phase, and secondly, the total species of Traguli caught during the 2009 to 2013 intervals regarding the physical positioning of camera arrays. Applying the Simpson's Index and SDI to the general overall numbers of the Tragulus species monitored over the 5-year period in all camera arrays yielded some interesting results. The total results of each animal was recorded as n and subtracted by n-1. The total number of all species was then added. This number was subtracted then by the grand total of n-1, leaving 3,628. The grand total of 8,422,240 in the n-1 column is then divided by 3,629 times, leaving and multiplied by 3,628. Here the Simpson's Index was represented as 0.64, which had to then be recalculated by using the Simpson's Diversity Index, SDI, by 1 minus d. 0.36 represents 36% chance in a scenario that 3 individuals in the community will not be from the same species. Out of 100%, this represents a moderately diverse community. The Simpson's Diversity Index formula was used to interpret the moon phase cycle and camera array positioning over a period of time. Even though there was an overall lower diversity between all Traguli species, represented as 17.3 and 15.1% during the full moon phase 4 and waxing gibbous phase 5, you can note the greater number of canchals being captured by camera traps during both of these phases of the moon's cycle. By observing this graph in the other factors results, a definite trend emerges which indicates similar feeding patterns and behaviours, but in array 1 all species peak in 2011, in 2012 and decline in 2013. This trend could also be influenced by human-related factors such as logging areas adjacent to array 1 and dispersal patterns that may reveal the borders of their home range. It can also indicate possible competition between each of the 3 Traguli species, since there is an overabundance of canchal over the napu and javanicus throughout the year 2013. More data is required to determine longer-term trends and abundance throughout moon phase in Traguli species, as the sampling periods in this survey are insufficient to come to any definitive conclusion. Furthermore, without any recorded geographical context to this data, we can only make assumptions as to the differing factors affecting diversity in arrays 1 and 2,